Well, thank you, Professor Paulraj, for meeting with us. Really grateful for you taking the time.
You're welcome.
And just to introduce myself, I graduated from Stanford, undergrad, master's, PhD, and I've been working on entrepreneurship. And so I actually initiated the meeting just looking for general advice because I remember I met you a couple times. But then I got the idea of making it into a podcast. So I thought that would be fun. Daniel,
Yeah. So, I'm actually really excited about interviewing you. I feel like you're the first interviewer that we're doing this podcast with. Interviewee, I'm sorry. I'm Daniel Kivitinos. I'm a transplant from New York. You know, the goal of interviewing you is to see and sort of pick your brain on like what sort of like your life and the experiences you've had.
And to kind of learn from you.
Yeah, and kind of
share your wisdom.
Cool, sure.
Yeah.
When you developed multiple input, multiple output technology, and that's kind of a key to the 4G and the LTE and some of the Wi-Fi network, what was your creative approach on trying to invent that technology?
Let me go back a little bit about my own career. I spent actually most of my career in India.
In the Navy, right?
I was in the Navy, but I was never driving ships. I was always in
labs and stuff.
R&D, mostly D.
You were leading labs.
I was my first. I did for 10 years. I was D guy in India building military sonar systems. Now we had a war with Pakistan, and we lost a ship due to anti-submarine action. So those days, even today, a lot of Indian military equipment is imported. We buy it from, those days we bought them from UK, but now we tend to buy it from Russia, increasingly from the United States now. But in 71, we had a war with Pakistan, and those days our ships were largely UK. And our top ship, anti-submarine ship, was torpedoed. And that sent a big shock. We lost a lot of lives. And so I was on kind of deputation doing a PhD at IIT Delhi, one of the good schools in India. Yeah. I was there only for 2 years. I was only given 2 years. So I was back with the naval headquarters when we had this war. And so they asked me, can you do anything about the sonar, which had obviously not detected a submarine? So I just went back to the university happily and then did a project there which became very successful. We built a new sonar inside the university. Not easy to do, but we managed to do it.
And that was the APO?
No, that was earlier. That was sonar 170B.
Oh, okay.
170B, which is the British name. We sort of took the sonar, threw out all the electronics, kept the transducer and all the heavy engineering part. We didn't want to touch that. But all the electronics, we sort of modified it. We changed the waveforms, the signal processing. It was a big success, and we sort of improved the performance dramatically and came up with some very nice ideas. So that was then productionized and put into all the ships. That was a 2-year kind of a project, and I spent a year in England, working as a research scholar. And then I came back, and India was looking at really top, a world-class fleet sonar for its, because this sonar I sort of modified or improved was the searchlight sonar, which is like, ping, receive, step, step, step. It's very slow in doing a scan. So you want to really transmit all around and get back all around. It was called panoramic sonar. So that was the standard state of the art. So we were looking for a state of the art sonar, and I think we actually were interested in the American one, but we wouldn't get it from the United States. Didn't want to sell it to us. So I said, no, let's build it on our own, and that was the AVSM project. And that was a very successable system. That took about 6 years to build.
And that was modeled off the U.S. technology?
No, it was really our ideas. Basically, I was in charge of the project, project leader. It's just, ideas coming out of my brain. Because we had access to what the Russians were doing, because we had a lot of Russian sonars by that time. But we also seen Europe and Americans, we didn't have very much ideas what we have. I think sonars are very classified, pretty secret stuff.
And the sonar was mainly for the ships under the water.
And this was surface ship sonar, which is either operating off a transducer, which is below the ship, or in a fish, which is towed hundreds of feet in the water. It's like it looks like a dirigible balloon, one of those kinds you see up there. but it's in metal casing. It's stored deep in the water. That's because propagation of sound in the water has lots of problems, and by going deeper, you get better ranges and so on. So it's called variable depth sonar, VDS. So we had those kinds of transducers, and these transducers were massive, and they would cost 15, 20 tons of equipment. A big, 5-6 feet diameter and about 7 feet tall, containing hundreds of elements or transducers. So this is the transducers part, which is a thing, but all electronics was inside the ship. And so that is a very big, very, very big project. Hundreds of man-years of effort, and very, very successful. And I think, there's certainly anything better than anything we saw in Russia or Europe, but we really couldn't compare with the American, but I thought we were better than the American fleet sonar those days was sonar called SQS-56. We had some idea what it was doing, but I thought we were probably very comparable, if not better.
And better than Pakistan.
Big one?
And better than Pakistan.
Oh, Pakistan. Yeah, Pakistan never had anything like that. So we were. So this was very successful and became India's really first major success in electronics for the country itself. Not only for the sonars, for the country.
And that was before the big IT boom.
Well before.
Yeah.
And in fact,
this was the 70s. Was this the 70s when?
This is between 77 to 83.
Okay.
83, and the IT boom started. A little bit towards the end of 80s, and so this actually gave, I think, the confidence in India that we can build world-class systems. And for some reason, the word world-class is always pinned on the sonar thing. This is really state of the art, and so that was very successful. And as a result of that, the Indian government at that time, Mrs. Indira Gandhi was the Prime Minister. Indira Gandhi, she was assassinated later.
Oh, yeah.
A lady, yeah. So a very strong woman. And she knew me and she said, wanted me to spend some time abroad. So I had spent briefly in UK at Loughborough University earlier, after my first project, and the first sonar project. So this time I said I wanted to go back there, but somebody in his wisdom said, no, I've been to Stanford, it's a great campus, why don't you go there? And do you know anybody there? I said, yes, I do know somebody called Professor Thomas Kala, who was a professor here. So he said, why don't you ask him and go there? And we would pay for it, the Indian government would pay for it. So I wrote to him, and he said, no. He said, he was my external examiner for my PhD thesis. In India, you send the thesis out to foreign examiners because, to get more feedback. Unlike at Stanford, examiners right here.
Totally internal.
So mine had come here, and that was a very, very. I did some thesis in signal, estimation of signals and random signals and noise, and nonlinear estimations. I used the tools of stochastic calculus, very, very esoteric stuff. Stochastic calculus, I don't know you've dealt with it, but it's not d by dx of x squared is not 2x, something else. It deals with functions which are everywhere continuous but nowhere differentiable. But so using those tools, I had a very, very successful thesis. It was very, it had unified the whole area very well and predicted a lot of new results. So that was very good. And so at that time, he asked me to come and teach a course at Stanford on thesis. He was very impressed. And Berkeley had somebody, professor, who was also said, why don't you come there, Eugene Wong. But when I went to Indian government, I was a lieutenant in the Navy, and they said, no way, you're going to the United States. The US was a big enemy of India. Because you guys had sided with Pakistan. And so they said, no, you can't go there. But many years later, that was in 74. But in 83, when I finished this project, when of course things had improved, so I wrote back to Stanford saying, can I come in? And Professor Kala said no. But then I sort of wrote back to him once again saying, why don't I show up? In fact, my bosses in India were saying you should go to Stanford. It's a nice university. I know I've been to the United States before that. I probably had been not been to Stanford. So I wrote back a couple of times, and I'm free. I was paid for. So finally, Tom said, why don't you come along? And so I was here I thought I'd spend a year and a half, but I spent more than 2 years here. And I switched back from all this practical stuff back to pure theoretical stuff, mathematical stuff. And at that time, the group was working on a very interesting problem. It's ultimately sort of led to MIMO in my thinking, where we have a number of antennas, radio antennas, the signals arriving at them from different directions. multiple signals. What is the direction of those signals? Estimate that problem. Turned out there was a long history of that problem. There were probably about 50 PhD theses on that. And there were a few well-known results here and now and then, and breakthrough ideas. And when I landed here, just before I landed, there was a guy called Ralph Schmidt in the Valley. He worked, I think, at ESL, who had a very fundamental idea called the music algorithm. A very nice piece of mathematics, using subspaces and manifolds. Beautiful piece of math, which is really, it caught fire. And his paper was one of the most cited papers at that time. So when I came here, I started looking at that problem, and so looking at his approach and working around it, make it solve more complicated problems and so on and so forth.
Did you go meet him in person?
Oh yeah, I knew Ralph very well, extremely well, and he was a brilliant guy. I lost touch with him now, but I do remember, later getting him sponsored for IEEE fellowship and things like that. I knew Ralph well, and so I was here, and I need to go back to India. I was still, at that time, I was a naval captain in Indian Navy, and but then when I built that sonar, AVSO sonar, we also had mechanisms for finding out the direction of submarines. The sonar was active and passive. So passive meaning only listening to submarine sound. On the passive side, we would be able to listen to submarine, localize the direction of submarine, and sometimes track it and so on and so forth. And I was looking at the ideas there about how to do it, different approaches. And finally, we landed up with an approach which turned out to be the right thing to do, but we had explored other ideas. So when I came here, the problem was very similar here, except we have multiple signals coming in. So the problem was a little different. So there was a core mathematical problem to be solved. And I was going back to my AVSO days, so I was trying to see how do I translate the ideas here. And I was sort of trying to get to it for many months. I was holding it in my head for many months. Finally, one day it cracked, 2 o'clock in the morning. I was actually at the office at Stanford when I was working on it. An idea came, and it took only a few minutes so it actually works. And we dubbed that thing called esprit, the angle esprit. And it turned out to be a pretty big revolution. For the last 30, 40 years, people have looked at this problem in one way, and this is a totally different way. And so everybody looked at it and said, this is a total breakthrough idea.
And was it this concept of like multiple antennas at the endpoints?
Yes, there's still the idea of antennas, but the thing that Esprit worked out was it showed that you form something called matrix pencil, and or generalized eigenvalues of certain matrix pencil where what you're looking for. So, all the earlier system you had to plot a spectrum and look for the peaks, and that would tell you the directions. And they had all the problems of biases and variance. This was more efficient. It method Kramer bound. So this is actually a totally new idea, and it just took off. Esprit became like earlier music became darling, and I think there are thousands of papers now on Esprit. I barely had this idea. We first presented it in a conference in SLMR, and my time was up at Stanford, and I went back to India. And one of the students of Tom, called Richard Roy, a very bright guy, he went on to build around Esprit, wrote a thesis on it, and he took it over and went forward.
So you had the concept, and he implemented it.
Yeah, I had the concept, and we wrote the first paper together. But Professor Kailak was the group head, so his name was always on the paper. So I was the first author. I had the idea, and Richard Roy helped me with simulations and things like that. Later on, he did some advancements on his own, and so on and so forth. But I went back to India, and I was back. I was still in uniform, but I was not going back to the ship, so I needed to do some D. I always say in India, we don't need R, we need D. We need to build some stuff in this country. Forget about research. So anyway, I was then asked to take over a very large electronics warfare lab. We have a large lab, probably 5,000 people, scientists, and I was pretty young.
In New Delhi? Or?
This was in Hyderabad.
Oh, okay.
So this is a very large lab, and the government said, why don't you take it over and run it as a director? I was a little unkeen. I was pretty young. I think the average age of the lab was 10 years older to me. Average age, leave alone. So in India, age matters. It's a more traditional society. So I thought I would have a lot of flack. And a lot of people said, don't do it. Start something on your own. I managed to, using the leverage of the Navy, to tell the government that let me start a new lab. And so I started a lab in AI and robotics. In terms of those days, we were going through hypercycle and AI here. So when I was at Stanford, though I was working signal processing, I used to attend some AI conferences. Feigenbaum, who lives nearby, was there, and so on and so forth.
You knew John McCarthy?
John McCarthy was, I didn't meet him, but I did know Feigenbaum. I knew a few more people. And I knew another professor in Carnegie Mellon called Raj Reddy, who's a very robotics guy. So I said, this is still far away for India, but let's start it and build a group. Eventually, we will do something with it. So I started the lab, but very quickly, India just then started a big program on to build our own fighter jet, fighter combat jet, like F-16 equivalent type system. Those days we were buying our fighter jets mainly from little bit the older versions from the MiGs from Russia, and we were buying them from France, Mirage, but we wanted to build our own. Spending a lot of budget on this, so that was already started. But at that time, the only guy who delivered a big system, which had proven, gone to production, was used by the armed forces, was me, the sonar, AVSM sonar. So the government, in their wisdom, said, you are the guy who can do something with this program, so why don't you take it over? So I had no idea of aeronautics or aviation, so I said, I will do it. But so I spent almost a year going to Air Force bases, flying in aircraft.
So it started out as an artificial intelligence lab, but then you switched to the...
I was just running the lab pro forma. Essentially, I knew my real job was that. So I was taking time. I was not doing much in the lab.
That was the main objective.
Yeah. So I started getting some flying experience, going to Indian Air Force. We had Mirages. We had the Sea Kings, which was the Sikorsky helicopters. So we had to put out aircraft all over the world. I was getting familiar with them, tried to understand the psyche of Air Force people. And one thing that always struck me at that time was I needed to get an Air Force officer to run this program. I can be the chief engineer, but I needed a guy who was an Air Force guy, because my worry was that this aircraft could kill people, test pilots. Test pilots are the most important people in the Air Force. If it kills a test pilot, Indian test pilot, Air Force would walk away from the aircraft, because somehow I sort of had that feeling. So I was lobbying the air chief. Now here I don't probably call them here. We call them chief of the Air Force, to give me a very bright, I think 1-star general from the Air Force to run this program. Because I'll report to him, but I'll be the technical guy. So all this is going on, and the Air Force was skeptical about what we were doing. All these tensions were there. At some point, the Navy, and I wanted to change the structure of the program, take it out of the government somewhat. Yeah.
Quick question. The Air Force guy was needed to basically make the project sort of safer for the test pilot, or to sort of
make the Air Force own the program.
Own the program. Okay.
It was our aircraft.
But you were building it, and if they died or got hurt, it would be from your team.
It's Air Force. They buy into it emotionally. Yeah. Then like in the AVSM project also, it was though I was the head of the thing. I did it under the government lab. The Navy had a lot of investment in it. Naval chief would not let that program die, because he really needed that sonar. So he did a lot of battle, a lot of politics in these things, to make sure the Navy gets that. So I saw that model. Otherwise, AVSM never survived all the politics without Navy being 100% behind it, saying, I want this thing, and I'm prepared to chop any amount of heads to make it happen. And of course, it helped them that I was a naval officer myself, so I was running the program, but there were lots of politics. And
part of what gives them that motivation is like, hey, we internally generated this.
And as well as, when the opposition comes from somewhere else, and we saw opposition, they would chop the heads, saying that, we don't want any, and this program has to succeed. So later, I always felt the Air Force must own this program, and they need to defend this aircraft, and then it might kill some people, but they will be behind it. So that was part of it. But I wanted structuring the program, take it out of the government. There was ridiculous bureaucracy. India is very bureaucratic. I'm immensely bureaucratic. We talk about bureaucracy in our country here as difficult. It's far worse in India. So I wanted to take that to change the structure. Eventually, I used to go to Delhi every week. I was in Bangalore. It was about 2 hours south of Bangalore, to try and push the papers forward. But eventually I began to feel that, there were lots of people opposing things. And so then I told the naval chief that I don't think this is going anywhere. So maybe I should come back to the Navy and build some submarines for you, something like that. So he pulled me out, but there was no project for me to run in the Navy. So I was sent to a large defense electronics manufacturing company called Bharat Electronics. They do all the radars and sonar. They actually manufacture the sonar that I designed. So they were a big manufacturing company. Largely their business model was to buy the design from outside, from Raytheon or from maybe Ericsson, and manufacture it for India to add some internal value. But design would come outside. So then I was posted there as director of R&D for them. So I had a large group of people I was running, but I also had built some labs called Central Research Labs, so more fundamental labs, where we're not directly doing product development, but doing a little bit advanced development, building some more skill sets to get away from the mindset of importing technology, but creating our own technology. I was there for 2 years, and meanwhile the Indian government was trying to buy a supercomputer, the Cray from the United States. And we, in our wisdom, said, we will sell it to you, but we are worried that you will use it for nuclear programs, and we don't want you to do that. So we're going to put a U.S. monitor in the computer center to make sure what the job loads are not nuclear. That was too much for India to take. So they said, no, we can't do that. And somebody who I knew called Mr. Petroda said, Paul, well, let's go and build our own machine. Can you do it? So I started to work on that in parallel. And clearly we couldn't do a Cray-like machine because we didn't have the...
Wait, you started trying to build a supercomputer yourself?
Yeah, so this is a national project.
Okay.
So I was put in charge.
Cool. Okay.
Yeah.
Wow.
And as a side job to my main job, which is running this R&D group for this big company. That company, by the way, had 20,000 employees, but R&D was about maybe 1,000 people, and I was running them. Plus, I had a central research lab. I had a research lab I started. So this is the second job I had. And but we knew we can't take on Cray or take on IBM. But there was a new idea coming up. Those they call parallel computing. Just buy, the Sun chips from the United States, which was you can buy them, and put them in parallel and build the software around them to make them. They won't scale well in every job, but some jobs they do well. And there have enough jobs where they may be useful. So let's build it. And sometimes, we always found this also. Whenever India wanted to import some technology, usually they'll say, no, we can't give it to you. But we start building on our own, then they say, okay, maybe we'll sell it to you because you'll build it anyway on your own and we don't want to be left out of making some money. Yeah. So this is also a way of that threat. We can do this on our own and maybe then they'll come back to us. So this project also started and then, I was pretty well known in India, mainly for the AVSM, but I think and I was, Indian bureaucracy doesn't like people who are well known, so running into a lot of problems. So around 91 or so, I wrote back to Stanford when I came up with the Esprit algorithm, long 85. Yeah. Stanford, Dr. Prusakala said, you want to come back here, join the faculty, and, we will make it happen. Nice. So 91, I thought back to saying maybe I should come back and at least spend a few years and get over, India is proving to be difficult with all these politics. People, a lot of people shooting at you.
Yeah.
And I couldn't take stress that well. So we said, come along. So we were going through, I think, a little bit of recession here and I think a little difficult. But I came back and...
just a quick rewind. Did you say that you knew Gandhi?
No, Indira Gandhi.
Okay, so not the actual Gandhi. Okay.
She was not a relation of Mahatma Gandhi.
Okay, yeah.
Yeah, but she was the daughter of Jawaharlal Nehru, our first prime minister.
Oh, then
she became the prime minister herself.
Oh, cool. Okay.
She was very powerful. She was like the Maggie Thatcher of India.
Yeah.
And she was assassinated by her own bodyguard. A very tragic story.
Yeah.
Right. So... Okay. So I came back, and then of course you don't walk in as a professor at Stanford. You came back. I joined as a postdoc. I used to be director of a large lab in India, but it came down all the layers down to the bottom layer. And then they started this process of getting me appointed. And
so the professors, to get you to come here, you had to. That was your entry point, and then once you were here...
Basically, like a professor myself here, I want to hire a postdoc, I just do that. If I have the money, I can hire anybody.
Oh, okay.
I just hired like that.
Yeah.
Then, of course, I think...
it reduces the bureaucracy of approvals and stuff.
Not really, but I just was already sitting in the country. typically when we hire someone, he's already got a job somewhere, he may remain there, we may interview him and all that. But finally, if he wins normally it's a competitive bid, right? We go out with the requirement and people apply, and then we go through the process of picking the best candidate. So instead of doing that while sitting in India, I was sitting here in the postdoc. So I was the postdoc. And that's the time. So so happened that I needed to get some salary, and there was a very well-known math professor called Gene Golub. I know you know the name, Gene Golub. He was a very well-known person, wrote a lot of books. And he had a DARPA program on interference cancellation problems. For example, the problem he was looking at was an Air Force reconnaissance aircraft flying very high and trying to read, what they call copy, signals on the ground in order to figure out what's going on. These are enemy radios. And now, on the ground, two radios are like 30 miles apart, and these radios are combat radios. They're only talking to a mile, from the platoon commander to some soldiers, to short-range radios. It turns out the propagation loss is very high on the ground. So a radio using a frequency F and frequency F can easily coexist without any problems. But at 70,000 feet, the propagation is very low. So both these radios will look in the same channel. You can't figure out what's going on. So you can use antenna arrays to sort of use signatures to separate them. So there was a long history of that problem. We call it signal copy problem. There were tens of PhDs and some algorithms which were obviously used by the Air Force. It was secret, I didn't have access to it. But we had a project here saying that some of the algorithms were not stable mathematically. So can you use some better mathematical techniques to make it more stable? So Professor Golub had this project, and I was attached to him, saying, why don't you earn my salary working with him? Till my appointment process went through, and there was no guarantee that I would win the...
Oh, you were a postdoc for Gene Golub.
Yeah, so I sort of worked with him. I was actually sitting in the E department, but I was working with... But at that time, we would do simulations of data using MATLAB, some tools. I always felt that, we should have some real signals, don't create the mathematical signals and then try and solve the problem. Let's have some real signals.
And this was around 85?
This is 91.
91.
91. Okay. I mean, I came 91 in October, so it's 92, around 91, 92. So we had this prototype very quickly built, and we were trying to get some real signals for a real wanted signal and interference signal, and you want to separate the two or cancel this guy. So we were doing it, doing this on a PC. The way it works is the signals are, I just took cordless phones those days to act as signals. So those guys are too close to each other, the system will break down because it can't see difference in signatures. But the far apart, it will work. And that's how it behaved. But one day it rained in Stanford, so I moved that equipment into the foyer of the building, and for some reason I noticed that when these two cordless phones were next to each other, or maybe two students standing next to each other, I could still separate them. So that was unusual. That was startling. It should not happen because. So then it quickly occurred to me that the multipath effects of bouncing on the walls was making it happen. And so that was a kind of a new discovery for anybody in wireless, that you can actually separate signals next to each other because of multipath. But it wasn't relevant to the Air Force. Air Force problem had no multipath. This was aircraft flying at 70,000 feet. There was no multipath there. So it's irrelevant to that problem, but it's just thinking about it. So I was having a haircut, I think, 3-4 days later. Then I said, what happens if these two signals from two different radios come from the same radio, and you put them on two antennas, and maybe you can make a little bit of calculation show that you can actually double the capacity. You have 4x4 antennas. You need to have as many antennas as on that side as this side. So if you have two antennas there and two here, you get twice. So you get 4 there, 4 here, 4 times. And a little bit of the real detailed proofs. Very esoteric, rigid proofs I didn't have. But quick back of hand calculation showed it does work, and it was visible.
Did that insight, like in part, come from your background in the parallel processing?
It came partly, I would say, from my sonar background. So sonars obviously had good understanding of multipath. In sonar, we did beamforming. We were doing a lot of array processing in sonars, a lot of array processing. So I had good intuition for those things, and I think that helped. And of course, I had worked a couple of years in directional arrival estimation at Stanford, theoretical stuff, Esprit, and in 84, 85. I think all that helped. And so while having this haircut, I said, we can actually, by having multiple antennas at both ends and doing the right coding and encoding, you have to do some processing. You can actually make a signal bandwidth, like you have, let's say, a 1 megahertz bandwidth. You can make it look like 2 or 4 or 5 or 8 without any penalty. Because you get it for free if you have these antennas, you do the right coding. And so I had some calculations to show that worked. So then we wrote a patent. But at that time, everybody I talked to in the cellular world, we were still using AMS phones. And this wasn't good fit for analog technology.
And by the way, that was the MIMO key insight.
That is the MIMO. Multiple input, multiple output. Multiple inputs from antennas, multiple outputs at the side.
And were you thinking like wireless internet at that time? Or
No, I was thinking about increasing speed
of
that thing. When this idea came, I was not looking at wireless at all. I was looking at the Air Force problem.
Oh, right.
But then the fact that you could do this triggered the idea of why don't we use communications? And then so that's how.
Because more data can be transmitted.
I can get more data, more throughput.
Yeah. Plus, there was no cell phones really back then. There were a few.
They were only analog phones.
Yeah.
And data it's only voice. There was no data. So people when I talked to some people, they said, this is too far off, and we don't want multiple antennas phones. Not going to work. But we were just talking those days about television called digital HDTV was just coming on board. So I went to Washington. Somebody here, I was still a postdoc. I think Professor Gallup, somebody paid for my ticket. I went there and talked to some people there, and they said, "This is real stuff. We want this kind of stuff. We're waiting for this, like worms coming out woodwork." They were trying to squeeze 20 megabits into a small channel, and they were facing this problem of bandwidth. I said, "This is a great idea, and we should look at it." And but the problem there was that, but anyway, there was a lot of support from that community. So when I wrote a patent, I said I pushed it towards that problem, but said you can use it for cell phones too. And but it turns out the HTTP community had progressed on their system too far around to use this idea. So it's finally being used now in Europe in digital broadcast, but 25 years ago it was considered too early.
They already started heading in a certain direction that
they didn't use this idea, so they had to change all the coding and all that, and it's too late. And so I came back, and then I found that there was no support for the idea. So I sort of...
I think I heard that you had a hard time getting it adopted by others.
Yeah, I would talk about it. In fact, I wrote a proposal to DARPA. And DARPA, go through the first gate of DARPA, they said, let's look at it more. I mean, we didn't reject it. Second gate, I remember meeting the DARPA officer. He said, I don't think it's going to work. It's too good to be true. I'll give you an example.
Like they don't believe the math. Like you showed them the math.
But even, I should be able to convince them, but no, it was. But it didn't quite, exotic math to be convinced. But here is the unbelievable part of it. When you send digital data today, like in your phones, in 4G, you send something called QAM. QAM is, suppose I want to send in one signal instant, I want to send you 6 bits of data. The way I do it is, I have 64 dots of signal. I send you one of the 64 dots. So that's 6 bits of information. Today we've gone up to 1,000 QAM. So one symbol I send you, I can send one of 1,024 dots, and you get 10 bits of information. So let's say you go back 64 dots, and I'm able to get 6 bits per symbol across the link. And let's say I put a 4x4 MIMO. I now actually can get, instead of 6 bits, I can get 24 bits across the link. It's 4 into 6 into 24 bits. So now you ask
the question. By having multiple antennas.
By having multiple antennas. Now you go and ask, saying, okay, you have this link sending 6 bits across. Let's say you're transmitting 1 watt of power. I'm getting some signal here, there's a lot of loss, but I'm getting, I need to get about almost a factor of 100 SNR, signal to noise ratio, in order to get 6 bits across. You can't get 6 bits with a lot of noise. You have to, noise must be really low so that the bits don't get blurred.
Shannon's theorem.
Shannon's capacity.
And
so let's say you have 1 watt coming across, you can get 6 bits. You put MIMO with 4 antennas, it's still only 1 watt. That means each antenna is only 1/4 of a watt. You see, now you can get 24 bits. That is, one can show that. But how much power you require without MIMO to get 24 bits on this side? You got to go from 6 bits to 24 bits. You'll require 1 million watts. These 4 antennas is equal to 1 million watts of advantage. When you say this, some people, they'll say something has to be wrong. You can't just get that kind of stuff. That's what I think.
They need a prototype, a proof of concept.
It's easy. I said because my demo of signal cancellation was analog. I wasn't doing digital, so I didn't have a demo of the digital value thing. But anybody in that art could figure out this is true. But DARPA said no, we don't think it's going to work. So that didn't work out. And I talked to the company, Qualcomm. They said no, they don't think this is going to work. It can't be true. Something is wrong. I spoke to some very well-known professors. There's the Professor Tom Cover was a very big name in information theory.
Yeah.
Tom also said, Paul, this is just too good to be true. There has to be something missing somewhere. You haven't thought it through.
Yeah.
But I have a demo of it, but analog demo, which is good enough. But nevertheless, I sort of said, this is not going to be. We can't build a company now to build something here. Let's wait for some time. But
you believed it was 100% right, and they were all wrong. So they were.
For one thing, is that if you pose the problem properly mathematically and then proof the capacity increases. I had posed it in a very general way, and I couldn't find a proof. But very quickly, with just some simple thinking, you can show it actually works. But a very rigorous proof I didn't have. Then it turns out only in 1997, that is 6 years after my idea came, after my patent, that somebody in Bell Labs posed a slightly simpler problem, and then proved it properly. And I think that sort of opened up the thing. Then they said, no, this thing has got proper mathematical basis. But anybody in art would have agreed with me that this actually, works. But nevertheless...
And you showed it works on a small scale.
Yeah. But after 87, I think literature began to grow. So MIMO became a real thing. So in 1997, so within a year, I said, okay, there was momentum building up in it. So I said, I started doing experiments in Stanford to see, does it work in cellular environment? Can you put antennas on a cell station stuff? Cell tower antennas. Those days, handsets were still considered too early for antennas. So we put a CPE, like a fixed modem with antennas, and does it work? And we had a lot of evidence from Stanford environment it actually works. So in 98, we started a company called IOSpan, and I built the first prototype of MIMO in the world. And I think Stanford had a website those days. I remember downloading Stanford website over MIMO link. It does inside a room. It's inside a room. And so then, because the VCs were trying to break the door open to get in and fund the company, so we had some money. And
you really encountered obstacles early on. And what were some of the approaches you took to try to overcome those obstacles? That you held seminars.
So what did was I began to run a workshop called Smart Antennas Workshop, and because MIMO was a big part of it, but. Using antennas and communications while it was a new paradigm. Nobody had talked it. So I built a very big group. So we used to run a workshop, and it became the global workshop for this technology. And people all over the world would come and say what they're thinking about. Then I would run a course of saying this is what we're doing at Stanford, and this is the state of the art as I can see it. And I would talk about MIMO, talk about other things. And so that was running for about it ran from 93 to maybe almost 2000, I think. Then my company I got busy in the company, and we didn't really do the workshops anymore. So that time we were the kind of world headquarters for antenna, multiple antennas. It's called smart antenna those days. We call smart antenna headquarters was Stanford University, and we became headquarters, and we can propagate ideas. And MIMO was the most important idea. There were other aspects of antennas, and so that's how it went on. And then IOSpan, then we focused on a cellular type system and said, what do you need to do? And so we married MIMO with another modulation technique called OFDMA. It's a modulation technique. It turned out those days CDMA was the dominant technique. You probably heard of CDMA. If not CDMA, forget about it. It was the Qualcomm was one of the kind of was a successful company in that area. It had an old history behind it, but Qualcomm pushed it forward. Like any startups, ideas are cheap. It's making it happen was always a tough thing. So they made CDMA successful, or trying to make it successful those days. And because they didn't want to hear OFDMA and MIMO, and that would have been a big problem for them. So I remember fighting with, talking to them and getting a lot of pushback.
And that's why, in part, you decided to found IOSpan to sort of commercialize the technology, because the others wouldn't want to adopt it.
I would say, I wanted to be an entrepreneur, and I said, here is an opportunity to building a company and building a new technology. For example, a little earlier, but in the early 90s, Qualcomm had grown, and they'd taken CDMA, an older idea, but put some new things into it and made it into a successful company. So, and it was considered to be 3G or 2.5G. So I said 4G has to come, and if you want, and I was also convinced that CDMA doesn't scale to high-speed link, broad internet. When you want 10 megabits through or 5 megabits through, CDMA will not scale. It was very easy to show that. And I said, but MIMO plus OFDMA will do the right thing. I was convinced of it. So to build a company to demonstrate that was the idea.
Were there any other competitors sort of at the time, like someone from MIT doing some?
There was a company called Flareon, which was a competitor, which came out of AT&T Labs, but they didn't use MIMO. But they did use OFDMA. They called Flash OFDM. So they did OFDMA, but MIMO was the real secret sauce to broadband. OFDM was only, what I would say, is also an older idea. It came back in the early 60s. It avoided, for a very broadband channel, CDMA fails, but MIMO would work well in broadband channels, like 10 megahertz, 20 megahertz, and all that. So OFDM, so they used Flash OFDM, but MIMO was ours, and we had no competition. So we built a system ground up from chips to boxes to base stations, the whole thing, and we had one customer, but clearly it's clear that going into to become a mobile standard, you have to standardize it in the standards process, and that was not beyond our ability.
So to be successful getting IOSpan off the ground, you had to kind of build like the core infrastructure, like.
No, we had to build all the boxes to deploy the system. So we had to have the base station, build the base station antennas, the base station, and we had to build we were not doing
devices.
Yeah, we had to be the client side, the CPEs. So all the electronics that today, like AT&T uses to deploy the system, we had to build it ourselves. With even the network management system, everything had to be built ground up.
You had to raise a lot of money for that.
We raised $70 million.
How much? 70 million?
Wow. And so we are one customer, and clearly running out of money. So we had one or two very interesting offers, but our board wanted whatever offer came, which was a very interesting offer. Said no, we want those days. 91 was a huge, the internet bubble, peak of the bubble.
98 was like perfect time to raise money.
98 was the perfect money. 2000 with bubble was at the peak.
Yeah.
So.
It's a good time to sell a
offers
company.
of 800 million. They said no, we want 1.5 billion.
Wow!
So this is unbelievable. So and I was always
that was when you sold to Intel, right?
So Intel then bought the company, but for much less money. By the time Intel came in, the bubble had burst. Bubble had burst. Bubble had burst, and so it was not good news. But nevertheless. Intel bought the company, and but they were convinced, I think, fortunately, that this was the future of wireless internet. They wanted wireless internet because they felt that wireless internet will propagate sale of PCs, laptop PCs. And so they needed wireless connectivity, and then they can push their Pentium processors through. They're only interested in selling Pentiums. They're not interested in wireless, but they could sell more if they had a wireless link.
It's a means to the end of selling more chips.
So they backed this technology, and they call this technology WiMAX.
Yeah.
And I was an advisor to them. And Intel is a huge company, and wireless was never fully part of the DNA. I was sort of struggling to build a team together. They had some good people.
Oh, you had to work with Intel?
I became an advisor to them. I didn't want to be an employee with them, but I was still at Stanford.
Yeah.
And but they picked up a lot of good people from the company, and so then I sort of realized someone who was doing some chips for DSL came by saying, Paul, would you be interested in doing a chip company for wireless? So then I was looking at Intel, and so I said Intel was making this into standard, making it global. I said, okay, let's go and build chips for that standard, WiMAX, because now it's happening. Intel is backing the idea. So we formed a company called BSEAM, and that got acquired by Broadcom later.
Yeah.
So, but to go back to MIMO. The leverage is so huge. And now what happening is we're now moving to millimetric wave where for example, let's go back to standard cellular today. In LTE today, the MIMO order is 4x4. You can go up to 4x4 MIMO today. Why not 100 by 100? The problem is, first of all, at the base station, these antennas are very big. You put 100 antennas in the tower, there's no place for anything there. So there's no real estate available for putting more antennas at the base station. And the handsets also cannot put too many antennas in the handset, right, because of a variety of issues. So today, at the frequency we operate today, 1.1 gigahertz, 2 gigahertz, 4x4 seems to be around the maximum. And even in Wi-Fi, you see these antennas taking out routers, 4x4 is typical. It's going to go to 8x8 soon. But in millimetric wave, when antennas get really small, you can go to hundreds of antennas at the base station. So now MIMO becomes so much more powerful. So the huge leverage of MIMO, because now MIMO is now the core of all Wi-Fi, all 4G, LTE. But in 5G, in the future of Wi-Fi also goes to its own generations. MIMO is getting more and more.
Antennas shrinking is sort of the key.
Because antennas typically are half lambda dimensions. Standard simple dipole, what you call patch and half lambda. And the lambda today, my 4G phone is working at 900 megahertz. Lambda is 3 feet. At 28 gigahertz or at 60 gigahertz, that's what the 5G will do. Lambda is just 2 millimeters. So, and I can, from that antenna, I can go to such a small antenna. So in this plane, I can put 10,000 antennas. I get a leverage of 10,000 speeds. And so, no, it's so
that really
MIMO is huge now.
Transmission.
So it's already huge today in current systems, but even bigger in the future.
How do you see it progressing? Like, let's say 10 years out, 20 years out, what kind of speeds could we...
Right. I would say that the one of the issues, of course, is when you go to higher speeds, is also the ability to process, because it turns out the decoding you have to encode and decode. Encoding is usually simple, but the decoding can be really complicated to do. So today a 2x2 stream itself is challenging actually. A 4x4, it's almost impossible to do it optimally. You got to sort of back off from optimality and do it without suboptimally. But at a large number of antennas, the processing throughput becomes a challenge. So there's some limitations to how much you can scale it, not because of MIMO doesn't work, but you just don't have the power to do these things properly and so on and so forth. So the leverage will probably go to 100 at some point. How soon is hard to predict at this point in time. And there's a slight version of MIMO called multi-user MIMO. So there, instead of sending all the streams to one guy, you can generate 100 streams, but send them to 20 guys with 5 streams each. We can do that also. There, what happens is, it is nice because the phone only needs to have 5 antennas, but 20 of them participating simultaneously. And then the processing per phone comes down. And So there are a lot of ideas called the multi-user MIMO, distributed multi-user MIMO. There's a lot of variation of MIMO now. So and 5G has embraced all of them. Next generation embraced all of them. Wi-Fi guys also embraced all of them. And I think where it'll finally pan out is still a little early for 5G to say that, because 5G is still about 2-3 years away. It'll first come, I think, in fixed wireless. We're trying to build gigabit pipes to homes. I think that's where MIMO will come in at 28 gigahertz and give you not a huge leverage, maybe a leverage of 4 initially, but it'll increase after that.
And that can be used within the fiber optic cables to the.
So the idea is to bring fiber optics to about every 10 houses.
Yeah.
And then fiber optics, every house is too expensive, because it takes about $4,000 to run the cable to your house, I believe. You've got to dig up the street. Yeah. And then the guy said, I don't want the service. That's a lot of dead money. Yeah. So you don't want to do that. You want to bring it to a point like that, 15, 20 houses around you, and then if somebody wants to sell him a modem, if he doesn't want it, fine. At least 10 customers will pay for the cable. So it's a much better business model. Yeah. Google tried fiber. It hasn't worked out.
Really?
Yeah.
Okay. Yeah, I remember they were trying to give it to the Stanford faculty.
No, we have it. I have fiber. You're free, but this is free, so I don't want to pay for it. I'm happy with it. And Google's put the money in. But when have a commercial operation, it hasn't succeeded for them. It's too expensive because a lot of sunk cost. So for wireless is beautiful because you only sell. First of all, the modems are much cheaper to run. Once fiber you got to dig in is expensive, but the last 200, 100 feet meters it can be purely incremental. If somebody wants to buy a modem, he pays $50, buys a modem. If he doesn't want it, that's fine.
And it solves a lot of other problems. Like there's countries that don't have any cables running in the ground, right. So they just have cell signals. So it'll be really.
So it has in many ways, wireless is really the way to go.
Yeah.
So it will come in initially as fixed, but finally handsets will have it. So there's a huge, today 5G. Every day there's a huge conference somewhere in the world, a lot going on, and so it turns out MIMO, and then the pairing of MIMO and OFDMA was done in IOSpan. I didn't invent OFDMA. OFDMA was invented in Bell Labs in 1960s, but the pairing was a critical pairing, and I won't go into detail why, but that has now become everything. All current systems are OFDM, MIMO OFDM. All futures MIMO FTM. So that became a rock. I can't see it being shaken now because it's so fundamental. So I was very fortunate.
It's like integrated in the infrastructure and everybody's building off of it.
It's that combination. So MIMO, it turns out there are other ways of doing multiple access or modulation techniques. Spectrum, CDMA works that way. MIMO doesn't work with them very well. It works well with OFDM. But MIMO is such a huge leverage and since OFDM works well with it, OFDM and MIMO got married together, and it was hard to separate that. So that's become the fundamental thing, and I can see it being there for forever. And there have been many attempts to see whether they can find any better ideas, and things come. So it'll be more and more of MIMO order, more and more of bandwidth, and OFDM is going through what they call as numerology. That means normally in Wi-Fi we do OFDM with 56 tones, and LT we do with 1,000 tones, but people will bring in more flexible toning and things like that. But basic ideas are the same. So I was very fortunate to stumble on this idea in 1991, which came not by thinking about anything, but actually doing an experiment. The experiment said something was funny there, and that triggered the whole thing. But I would still say
that you couldn't prove it sort of generalizably.
No, I could easily prove it, saying that it works. But getting a rigorous proof I didn't get that, and that needed mathematics that I didn't have. I'm a naval guy. Never had any formal mathematics. Whatever I learned is all self-taught. So somehow I didn't have the math to prove it rigorously. But anybody who knew wireless would agree with me that this does work. I can prove it with the 99% accuracy. 1% was missing.
Well, at that time, were you kind of like the crazy guy in the room pitching this idea and nobody else believed you? Or did you have other people that kind of backed you and supported you?
I would... I'm not a great communicator, but I didn't have, Tom Cover was suspicious. Yeah. He just said, because I told you this idea that with 4 antennas, you're making 1 watt look like million watts. you can actually, we have 8 antennas, one watt look like 1 billion watts. True, absolutely true that you wanted the speed that 8 antennas gave you, you would do with one antenna, which is technology those days. You needed 1 billion watts. I mean, it's ridiculous, of course. So when you see in that light, people say there has to be something wrong. How can you get that much leverage? There must be something wrong here. So there are a lot of people, for good reasons, said no.
It's kind of like people are thinking linearly, but you had this paradigm shift and it created an exponential.
Right. And so DARPA said no.
It seems crazy.
But there was a guy in National Science Foundation, John Cousins. I wrote me a beautiful letter for my 70th birthday, who believed in it. He gave me some money. So my first money came from NSF. And
did you have to go to Washington and pitch him in person?
Yeah, I did go, but it turned out the moment I landed in Stanford, there was a seminar on future of wireless or something like that in Colorado, and somebody said, "Why didn't you go for it?" I went for that. There I met John Cousins, and I told him, he got to know my background. I built sonars, high-speed computers. He said, "Paul, you've done everything, so you're a guy that we should back you. You're a guy worth backing." Because the problem in a lot of research is that people are sitting in two different tunnels, two stovepipes. Practical people and somebody who can bridge both is very valuable. So he saw that.
That's really interesting. So he backed you because of you and not because of him believing the concept.
I did go to him. When I went to meet the HTTV guys and pitching the idea to them, they were very receptive. I did go and meet him. And I told him on the board how it works. He said, "Paul, it's a great idea." Yeah. But later on, I sent a proposal. I think he had a confidence to back me. And he always backed me all the time. So he just retired. So I had some thing. But it's only, I remember when we got it working and Qualcomm came and saw it. Then they said, this has to be true. I mean, until that time, they found every reason why they thought it may not be right. Right today, then of course Qualcomm now is you ask Qualcomm, they're not CDMA, they are MIMO FTMA company today.
They had to pivot
change the
because of technology changing. Yeah.
So that was the story of MIMO, and I had wonderful students and postdocs. Now I'm retired. I'm not active there anymore. But I've been sort of playing in the valley a little bit, and I did another small startup building, matching machine learning with Wi-Fi. The idea here was very large Wi-Fi networks. I didn't realize that
machine learning as in deep neural.
Machine learning as what we. But here is the problem we were trying to solve was this. This started 3 years ago. It was bought by HPE last year, and the idea there was University of Washington has 18,000 APs. I didn't realize that. Ohio State has 15,000 APs, and they have IT staff monitoring what's going on. And the question is, a lot of things there are a lot of things that go wrong. People have difficulties in handing over, or slow servers, or DHCP requests, or fail. So variety of people see their connection problems, variety of problems. And IT staff to figure out what's going on, is this something anomalous? Should I do something about it? What should I do? It's getting more and more difficult because the networks are getting denser, more interference, and so on and so forth. The question was, can we bring in machine learning to try and help it out?
Looking for patterns in the network behavior.
That's right. Looking for anomalies. Yeah. And it turns out that's not easy to do because what is anomalous, say, in a dorm may not be anomalous in a classroom because they're very different environments. So we have to learn what is anomalous and then flag, and then try and help root cause it. And we might have seen that this anomaly has, in Ohio State, root cause might have been nothing more than some software bug in the Apple release, perhaps sometimes.
And you have a set of training data that's human curated.
Not so much. The most paradigm we've used are not being based on supervised learning, mostly unsupervised. We use unsupervised. Support vector machines and k-means, clustering algorithms, looking always for outliers. This should be the pattern now, but there's some outlier that doesn't look okay. Maybe it's okay, but we go and dig into it and we find something there's a problem. Then we flag it and it's presented with IT staff saying, we think there's an issue here, and maybe we think this may be the root problem that you're looking at.
It creates kind of a recommendation engine to prioritize the different issues.
To make the job of IT staff easier and
to augment their capabilities.
Yeah, it's augmented. It's not replacement human intelligence. Augmenting And very good feedback. And in fact, HP, Aruba, HPE bought a company called Aruba, which is a big Wi-Fi company.
Yeah, David Sheridan's company, or was it
David? I don't know. The Aruba was started by
Andy
I think a guy called Kirti Malhotra, who's now running it.
Oh, okay.
Nice guy. So in fact, I'm an advisor to him. I didn't really follow the company after we acquired it. I'm an advisor to him. And so they bought the company, and they've been very successful. We call it Deep View. So I'm sort of now shifting my thinking about MIMO. There are tens of thousands of people doing MIMO, and it's too mathematical now for me. So
it's grown beyond your
it's huge. I also wrote the first textbook on it, but now there are hundreds of books. And a lot of my students are very active. A lot of my students now are some young professors and our industry, very active. They are, in fact, the first leadership tier MIMO in the world came from my group.
Yeah, Vint Cerf told me something similar. He said when I invented TCP/IP, like sort of creating the internet, it looked very different than internet now. Everyone's been building off of it.
It's gone. You know, I take, for example, in '92 when I had this idea. If you told me that MIMO and broadband internet will be here, what it is today, and MIMO will be such an important part of it, I would say you're crazy. I've never thought it so much.
Even you.
Yeah, I would say so, because it's just gone beyond anybody's. In fact, it's so pervasive now, smartphones and all that. So, yeah. So I've been moving. Look, I started the AI lab in India. Remember, way back. So I have some DNA in it. So I'm started looking at that intersection now. So I gave a keynote 2 weeks ago.
Those are the days of like expert systems.
Those days, expert system was a big thing, but it's not a paradigm people are using now.
Yeah.
So it's mostly now supervised and supervised learning. And I sort of believe that there are opportunities to improving wireless systems in different ways by bringing in these ideas. So I've been sort of pushing that now. That's become my intellectual pressure point at this point.
Wow. So you've kind of like shifted your focus to this advocacy role of approaching this.
Right. Because first of all, I could see, for example, in this other company, Rasa, that's my third company, we could see we added real value by bringing in machine learning not into the core of the technology, but in the management of the system, the network management side. But I think it can also play a role in the core. So I actually gave a keynote saying, here are some crazy ideas. They may be crazy, but some of them will be true. Let's think about it. Let's get the youngsters looking at it and so on and so forth. So I've sort of become, but MIMO itself, I'm not, I get a lot of requests to do keynotes. I stopped doing it because I think I'm way behind. Everybody else is ahead of me.
Yeah, it'll look bad if you're not abreast of the frontier when you're the creator.
Right now, it's mostly, but I would say that I spent almost 25 years in India and almost 25 years in the US. So I have 50. But India was always building stuff, and it's sonars. Then it became high-speed computers. I did a little bit of small other stuff like radars in this company I was in. And Stanford has always been wireless, because MIMO came in within a few months of coming to Stanford. So it built my future for me here. And I'm pretty involved with China and with India. And in India, my big thing, I'm very involved in India. You guys may not realize this. We have an idea of India being a very high-tech country. We import everything. Everything is imported. We have a lot of service companies. We do a lot of services now. Intel has 10,000 people there. And HP has 5,000 people there. But there's no much innovation there. Innovation is all here or elsewhere. So I'm trying to see whether we can build our own companies there, which can, be a innovator, and we have good people there. It's just that the mindset is not there.
And you're doing that by working closely with universities like IIT.
I've been working with the government a lot, but I find government is hard to move. So right now, in fact, I'm very active now in next generation of wireless called 5G. So I want all the young professors to build prototypes for 5G, get some hands wet, build stuff, like I always did. And and I said that's something good out of come along. Maybe they'll start their own companies and things like that. So I've been pushing that, and I've not been able to get funding. I went twice to India. We're hoping there's a meeting day after tomorrow in Delhi, which I'm not going back for, but I believe we'll get the funding for it. And I'm lobbying the Indian government to fund it. So in India, I'm involved with that. And I'm also a professor in China, a national professor, and they're sort of interested in my vision of what 5G is going to be. So I go there and spend some time with them.
What are the key leverage points on sort of making that change? Because you're kind of over here living sort of a privileged life here in Silicon Valley, but yet you want to help people over in there in India. Are you trying to approach it by like focusing on the government or the education system or industry?
I think right now mostly with the top schools, the IITs.
The technologists.
Yeah, but the government, I initially tried, I'm actually a global advisor to Indian government on telecom. It doesn't meet very much, but I did try to see whether we could, I always felt that in India there's a lot of knowledge of wireless because Intel, my own companies, all my companies have backends in India and got very, very good people there. In fact, I would say the chips that we built here were largely done in India. We had some supervisors here, but a lot of very good youngsters there. So
they can do it.
They can do it. They can absolutely do it. So I was trying to get the Indian government to find how to create more venture capital in India to help these guys build companies. But the Indian government, I think, has not been able to take that leap.
Well, do you think you could have invented MIMO from India, or you'd have to be here in Silicon Valley?
I would say, I had the idea there, but for it to have the traction it's had, it had to be here. Yeah. Partly being at Stanford helped it. I know you have an automatic credibility factor as part of it. Then and MIMO also I'm prepared to bet it'll be nowhere near where it is today if not started IOSPAC. And sure, it actually works. You had not handsets.
You needed that 70 million in venture capital.
Yeah, and we showed it worked. We had a full setup of 3 base stations in Santa Clara, and I still remember company coming looking at it and saying it actually works. And that took it into standards and then Intel. So I think that kind of leverage India would never have had. So it would have, not to say it not have taken off, but here I became the kind of evangelist for it. There, somebody else would have had to be an evangelist. So India didn't have the capital or the mindset to be able to push these ideas. Even today, we have virtually today we look at all the standards work done in Wi-Fi and cellular around the world. India doesn't participate. We are a no-show. So clearly, you had to be. Even Europe would have been difficult. I think you had to. Stanford, Silicon Valley was the right place to get to MIMO to come up with to be born in. Perfect place.
And were you thinking that before you came here?
No.
I got to be at Stanford.
I just had because I had this kind of offer. It was not a kind of offer saying because Esprit was very big. It was when Esprit came out. It was and I think it dominated research publications for years. So people said, Stanford, no, if you can do Esprit, why don't you come back and maybe do something here? So I had that offer, and then I was having my own frustrations in India. So I said, children were getting to high school, I said maybe they can come and get to high school and get to college here.
Yeah.
So it was I was really a kind of an economic immigrant, but if I'd got it from a second-class university in US, I wouldn't have come. I was already very senior in India, I was,
and you came here as a postdoc.
Yeah, I came at the bottom of the bottom. So, but because of Stanford and I sort of I knew people here, and I knew that it'll work out. So that's why I came. Yeah.
Did you have any issues like they always talk about people, really smart people from India coming to America having visa problems? But did the professors work that out for you to come here?
No, those days there was no issue at all. You just getting an H-1B or green card was so simple. There was no problems at all. There was never a problem, and of course, because my leaving India was heavily noticed in the papers because I was very well known, and even today you find a lot of blogs talk about me leaving India. And
did they feel like you were kind of abandoning them?
Not that, but there's always a lot of hard soul searching, saying why did Paul leave, but I left for very good reasons. The problem was my problem was I was successful very early in my life. By age 35, I was so well known in the country. I had the most successful project, and it was like everything else was here, and mine was somewhere there, and it was so successful that I attracted a lot of arrows, and so it became almost untenable to be hanging around.
Yeah, actually, how do they sort of shoot at you when you kind of stick your
Well,
head out?
I wouldn't go into it, but it was not.
Do they like kind of try to smear you in the newspaper or like?
No, none of that. It is that I think my problem was I was trying to frankly acquire power in the LCA program, the combat jet program. I wanted to take it out of the government, so that was all opposed. I think largely because they didn't want to, give me that kind of freedom because I've done pretty well with no freedom. But nevertheless, I would just say that I'm a U.S. citizen, I'm certainly loyal and thankful to this country, but also love India. And India is a great country. We have many, many good things for us, and we have a lot of poor people still. We have 300 million really poor people. So I really see it as my duty to help India.
Did you have any mentors here at Stanford that helped you be successful?
So Professor Tom Kyle, who was actually my examiner for my PhD thesis. Later on, he was my host for my visit here when I came here. And then later on, when I came back as a postdoc, he was the first guy who said, I'll give you an appointment, I'll give you a job here. So he's always been my mentor. He's not retired way before me, but still very much, he used to live nearby here, but he's moved into Atherton.
Wow, that's awesome.
And I also had a mentor in India, another my PhD professor in India.
At IIT New Delhi.
At IIT. And, I've known people in the government, and I'm still very connected. I have lots of friends in India.
And your family, I'm sure, right?
I have family too. Yeah. My daughters are here, but my sister's there. And I sometimes have to go back to India 10 times a year. Nowadays I go back 3 or 4 times. I'm going to be there next month. But I go back pretty often.
Imagine that you had a Stanford PhD graduate in the room, and he was about to embark on founding a software company. What advice would you give to him or her in terms of how to be more successful as a software entrepreneur?
Yeah, I wouldn't particularly put my remarks towards software, but I would say a few things. One, I think, is important persistence. I think. In all my companies, nothing ever goes as you want it to go. You go through very rough times, ups and downs. And you don't want to, don't lose heart. So I think persistence, I think, is the most important quality as an entrepreneur. And I think I generally have. I'm probably getting less persistent get old, but I've been persistent when I was younger. That's one. The second thing I think is it's very important to pick the core 3 or 4 people, the core of the company. You have to be very careful in picking them. Make sure they are really good people. Certainly bright, but also somebody that you'll have a different opinion with them, but somebody you can get on. You have some level of mutual respect that will overcome paper over things bad days that's going to come. So mutual respect but very bright people. I think if you have that and then you have persistence, I think that there's so much opportunities today. I think you're going to be successful. You'll find something. It's really, if I always say bet on the team, forget about the idea. Ideas, if not the first idea, second one will take off. Bet on the team.
And what were some of the key people you pulled in early on IOSpan?
All these companies always had
grad students,
former students. In the core was always former students. But, I always realized that in IOSpan we were building heavy iron boxes, heavy iron chips. These students from a PhD from Stanford, even though he's written a lot of papers, he doesn't know anything about building anything. So very quickly, you bring the sparks in and the thinking power, but you have to bring in some gray hairs who know, who experience of building things. So the core team is always my former students or somebody I knew. But very quickly, I would bring in more seasoned people. Would be build a company.
Also,
but I tend to use former students as the initial core because I know them. There's a relationship, so we can figure out the company, and then once the things are setting well, then you can bring other people in.
And you've worked with them for years, so you really know them.
You know them well.
They have the technology, knowledge, and skill.
Yeah. And then certainly the intellectual thing. You also know them. Usually, you know them well in terms of personal skills.
And trust.
And it's and the real thing is not knowing them well on a good day; it's knowing them well on a bad day.
I'm curious about some of your morning routines. Like when you wake up in the morning, what does your first 60 minutes in the day look like?
A cup of coffee, I think. But right now I'm involved in advisory roles with a number of companies, including Facebook and HPE, because they bought my company. I'm involved with another carrier, Vivint.
That's right. Facebook actually has those...
Connectivity Lab.
Yeah, they have they're doing some crazy projects where they're flying...
They have a drone. They have drones.
Drones.
They have satellite systems, and so I'm advisor to them.
Propagate internet.
Yeah, in other countries.
They want to propagate internet access all over the world. So there are a lot of very interesting projects.
I think it's smart they're doing that. They're sort of diversifying a lot.
Actually, how do you feel about that compared to Google's Project Loon approach, where they have these balloons?
Yeah. So Loon was one way of doing it. The corresponding way Facebook took was a drone concept. This is a solar-powered, it will fly for 2 months. All of them have the positives and negatives around them. I think both of them are persisting with that idea, and they're clearly not yet operational. But Google has gone through some compression. They've decided that there are lots of projects going on, and they're compressed back to 1 or 2 because they said they don't think they should be in business of building stuff and becoming a... here you're really playing the role of a vendor. You're becoming an Ericsson or Qualcomm. You're building boxes, so like Ericsson or Cisco. I think Google discovered maybe they don't want to do that. And I think Facebook is still sort of persisting, but they too have to figure out, because their DNA is software. How do they sort of get into these things? Because these are very heavy engineering systems, and it's a very different DNA. I'm deeply involved with them to try and help them and make them successful. So I'm involved with many startups too. So I'm busy with this sort of thing. Then I go to India very often, and quickly go to China and go to Europe. So I'm having fun.
What do you think is the highest impact technology that will help sort of spread the internet to another 2 billion people? Right. Would it be nodes in the sky or something?
So the satellite can play a role, but the problem with satellite is that if a very simple satellite, it acts like one base station. One base station, satellite covers hundreds of square miles, the footprint of an antenna. One base station doesn't give enough capacity. Because there are satellites now with hundreds of antennas which can form spot beams, and it can act like 100 base stations. But I think satellite has to act like thousands of base stations before it can compete with terrestrial network. Here we can put up a base station every 200 meters. Every base station, remember, has certain capacity, so you replicate capacity again and again. So satellites are more thin route. They're not dense systems. They're good for countryside, going fishing and all that. Mm. So, but nevertheless, as technology improves, they can be competitive. So satellites, then drones or balloons or loons, and then terrestrial systems. And each one has a different play depending on geography and other infrastructure around. But nevertheless, I think phones are now, penetration of phones, voice phones is 98-99%. Everybody has in the world. But broadband is still low. I think a really good broadband, like 10 megabit link, I think less than 10% of the world population have it. And about 50% of the world population has no access to data, internet at all. So we've got to connect them. And I must say that Facebook and Google are trying very hard to do something about it. And I think also there's good business models within these countries to do it also. So, but the value of the internet, I think, is huge as a multiplier for growing a country, advancing the GDP. So that's a big challenge for everybody, and that is going to happen.
Facebook and Google have a similar motivation as Intel in a way, where they want to sell more. Intel wanted to sell more chips, and so it's like an instant means.
Facebook wants to get more eyeballs.
Yeah.
So they're all driven not so by the core technology as much as by other things.
Yeah.
But nevertheless, I think
it's still a win. It's still a win if you can get internet. Yeah. You don't have it.
So I think that's getting. And even Winsor would agree, or Bob Kahn. Getting good internet access to the world's population will be a huge multiplier in every way. It will improve. Economic factors very strongly, and health factors, everything. And it's not there today. Even India, I would suspect 80% of India doesn't have really any kind of real internet. So very poor.
Yeah, it's kind of strange for me to think of it that way because I think of India and I think of advanced technology like the IIT people I met here at Stanford, but
it's actually the real truth is it's very different. And a few pockets like Hyderabad and Bangalore and Delhi, you see it looks like this country, but you go away 50 miles, it's back to bullock carts, and but everybody has a phone. Phone is really spread.
Using MIMO.
Well, yeah,
almost.
When they have a smartphone here, but in India, people with smartphones have become very cheap. They can't afford a data plan on the cellular. It's too expensive. It's expensive here, so they rely on Wi-Fi. So we need to bring Wi-Fi into India. That's way then they connect on Wi-Fi into a smartphone. So Wi-Fi is where broadband is spread in India.
That would be the first entry point to have the biggest impact.
Right. Because cellular, first of all, not people travel in cars. People go in buses, of course, and getting access to internet on a bus also is interesting technology we need to do. Here we bring them LTE to the bus and then jump on Wi-Fi. But India, that will be expensive. So, but Wi-Fi will be the way. Finally, the last 10 feet will be Wi-Fi in India. That's the way to do it.
What is the worst advice you've ever seen or heard being dispensed in your world, whether it be entrepreneurship or technology?
Probably the worst advice is, this is too hard, why don't you give up?
Yeah.
I've sort of seen that.
Connects to your persistence. Yeah. What advice would you give to yourself as a 20-year-old man or 30?
Probably to live a more balanced life. I've been too much involved in my job and technology, and I should have paid more attention to things outside those areas. I think I've been.
And by balance, you mean like more time with the family?
And more holidays and
exploring the world for fun, enjoyment.
Yeah,
that's really good advice.
And the reason for that is it's more life enjoyment, or it's like actually better for creative process or productivity, like in the end. Or
I think it's
more meaningful.
It's also important for people around you, so that you're not so focused on things. Yeah. But also I can't comment about the creative process, but if you're overworked and sleep deprived, you're not functioning properly. So to be rested and the big decisions, you want to make sure you make them when you're fully there. But I never really worked all that hard in the United States. In India, I used to work much harder. I was dealing with much bigger projects. Startup companies are still small compared to what I was doing in India.
Yeah, I think there's like 1 billion people in India.
Did 1.1 billion now.
Did you feel a sense of like intense competition, pressure, because you got these 1 billion people you're competing against?
Not really. Not really. I sort of stood above the curve very quickly in my life, right in the beginning. So I never had any probably was my problem was not enough competition. No, I didn't have that problem. And we talk about mentors. I've had lots of good mentors in India also, and I had to, for all of us, we are where we are because others have helped us. So absolutely.
And I'm kind of curious, what have you changed your mind about in the last few years? Yes. Like something you believe that was true, but you've shifted your thinking about?
I would say shifted my thinking about startups. I always thought they were easy to do because if you had an idea and which is doable and you can build it, people will come and buy it. It turned out that's not necessarily true. You got to convince people and so the idea of to create a market for it, because the best of ideas is if there's no sensitive to it, you can't sell it. So you have to create a market for it. You've got to evangelize it. So I didn't realize that because in India it's the other way around. Because we were importing, let's say, a sonar or radar. You can build it instead of that. You have an immediate customer, and they would beg you to do it. Here you have an idea and you can build the stuff, but nobody ready to buy it from you. So you got to. And particularly in the wireless world, it's a huge ecosystem, and that system doesn't move easily, So you have to convince many people, many layers, to bring a technology in. So it's much harder that way.
And what's the best approach on convincing people? Like showing them kind of
I think showing them is useful.
System?
Showing them is useful, and of course. But also, I got a feeling that a lot of people have blinkers and mindsets. So I think you got
even if the truth is right in front of them, they can't see it.
Like, for example, I think MIMO, to some extent, MIMO FDMA and what today 4G technology, we have to give credit to Sean Maloney at Intel. He's the guy who bought IOSpan. I mean, he could see in his mind's eye that this is the way to go. I don't think anybody else, any major company, which also looked at acquiring us, really believed that way.
So one of the approaches is like finding those visionary types.
We'll look for many people, and one of them hopefully will see it and connect. And then, then everything is different after that. But it's you may have the best mousetrap, but you can find that the people who should say yes will say no. Because I think decisions are not necessarily rational. A lot of things go, and sometimes it's not rational in a way because it may upset their own business plans or whatever it is. So it's very
Yeah, that's one of my observations. Like, part of the reason why you've been successful is not only that you're kind of smarts and technology innovation, but also how to navigate the human landscape. Like in the India military, how you were able to figure out, we need an Air Force guy to help push this forward and make it appear like kind of an internally generated project. And then being able to connect with the Intel guy.
That is a critical part of how it worked out for me.
And it's just kind of street smarts in a way.
Yeah, hopefully, I don't know. But certainly, we think it, particularly in just wireless, this is a global ecosystem. It's one person or one company can't move it anymore. It's you need to find partners, and you need to keep knocking on the doors all the time. So,
do you see any kind of like bad things or like threats or risks or like sort of negative consequences of some of your inventions, like MIMO? Or is it just all 100% good? Like,
I think the technology, I think it's I can't see anything bad about it, but certainly internet is certainly a wonderful tool, but it also has downsides, so we can clearly see.
Like cyber attacks, and like
all sort of things. Yeah.
So
I think it's and I think the world today to me it looks much more unstable and much more dangerous. Yeah, I mean, we have huge problems in the world. I mean, look at what the Middle East is in a bad shape.
North Korea,
Russia. Most countries are in turmoil. I mean, look at Brexit and what's happening here.
Syria.
And partly I got a feeling some of it is due to internet and the way fake news or whatever. But people are much less happy with what they have, and whatever the reason is, I think it's
destabilizing.
Something is destabilized. It's clear that the world is much more unsafe, and maybe the internet has been part of it. Has been a part of it.
Yeah, like for example, the Arab Spring, right? Twitter helped people kind of.
I think even Syria would not have blown up without internet. Syria. It started with one boy being killed, but internet spread that, and anger came, and then finally, the whole thing is a huge disaster. So it's wrong to say that that ignorance is a good thing, but sometimes without proper control, it creates problems.
I heard Alan Kay speak a little bit about this, and he said, some of these information technologies we've been inventing, we're putting them in the power of like so many billions of people, and it's almost like giving a caveman nuclear weapons. So
probably bad actors who can.
Yeah.
But on the other hand, it's produced, transformed our lives, made it so much more convenient, and of course, still transforms society. And I think, as somebody was pointing out, I think Warren Buffett, 100 years ago, 80% of this country was required to feed the country. Now 3% feeds it, and we export a lot of food. But 80% of jobs today is also going to disappear.
Oh yeah, like self-driving cars and truck drivers.
Sort of thing. Automation in offices and shrink down to 2-3%, and we have to find new jobs, new things to do. There's no clarity what's going to happen, and we can't see it happening. And and if we don't solve that problem, we'll have much more unrest, and inequality, all sort of things will come. So all these things are double-edged weapons. But that doesn't mean we shouldn't develop these things. But I think we certainly need more human factor skills in our society to deal with them. purely, just unleashing technology without thinking through the societal issues is a problem.
And I'm curious, or how has failure or apparent failure set you up for later success?
Yeah, I think I've certainly learned. None of these has been uniformly successful. There have been failures too. I would go back and say that carrying people with you, making extra efforts to carry people with you, and persistence. I think I would put them as two important things that.
Were there times where you didn't have persistence when you should have?
I would say that. I think I'm pretty persistent, but whenever
you have your limits when you go.
For example, coming coming here was a lack of persistence. I should have probably stayed on there and persisted and done different things there. So that is well known in India that I sort of quit, and I think that was a failure certainly. And also carrying people with you, it's important to carry people. Sometimes you're right, but that doesn't mean that you can ramrod it around. In fact, when I was doing my first startup, I would say this is much slower than India. In India, you're the boss. You say this has to be done, and they would do it for you, and they don't question here.
Like sort of hierarchical orders,
and everything worked very well there. But here, people want you to, they will doubt it and they will question you. Things slow down here. But the thing in India is that the boss, disappears or monkey takes over, everything collapses. But here, you have much more depth of thinking, so that even though the top guy disappears, a system can take over. It's much more democratic here. But it's slower. So I always, in fact, I quote Truman when he came to White House. He used to say, I thought coming to being president says, do this, do that, everything happens. Nothing happens in Washington.
Yeah, I think President Hennessy said that too about becoming president of Stanford. He, in the beginning, he thought that he would sort of set the vision and then rally the troops in a way to go in a direction. But instead, he realized his role was more just figuring out what the community wants to do, right, and help make that happen.
Yeah, he had I think we were trying to do a campus in New York, and
creamed.
He put a lot of mental energy into it, and finally didn't pan out.
That's interesting. So you viewed a little bit leaving India and running into that challenge and in a way quitting as almost a failure, and when you came over here, but in fact it ended up being. It enabled you for this huge success because you said you couldn't have pulled this off.
Right.
MIMO and
so I think I would never predicted that I would be lucky to have this idea, and true. But purely from Indian context, of course, a lot of MIMO has created jobs in India. We've got a lot of chip designers all over the place. But still, I think India would have probably benefited if I stayed on and led other things. And we're still, I keep saying, we're still importing technology. Maybe if I stayed on, I could have changed the scenario.
It was like a brain drain in a way.
Yeah, they call it that. Yeah. But I also justified myself. So I delivered 2 huge systems to India. 2.5. One small sonar, the big sonar, then the large computer, which was always successful. So I tell myself, I've done my job for the country, let me do something else. But nevertheless.
When you came over here, did you leave your parents behind in India?
My parents had already passed away.
Oh, they did? Oh, okay.
I'm enormously grateful for the United States for all the opportunities we had here. And so it's, and I still haven't lost my connection to India, so I've had the best of both worlds.
I'm kind of curious, what is one of the best investments that you feel like you've made, not maybe in money or time or energy?
I would say the best investments of energy would be starting companies.
Entrepreneurship.
Yeah, because you learn a lot.
And it's starting a company, not just a random company, but based on technology that you believe in. Helps you create.
Always broke new ground. And you started, you have no idea where it's going to land up. You have some idea that it'll work, but you know all the barriers out there. I think you learn a lot about not so much about technology as much as about human beings and how society works, and ultimately, today MIMO FDMA is everywhere. Every wireless uses that technology, and I can claim that I was a big part of that, and so it gives you some satisfaction too. the best thing I've done is start companies. And, I mean, certainly Stanford was good, research and all that. But the companies are much more challenging, much harder, much harder. But I think the most return on investment, I mean, not forget money, what do you learn and what you can contribute to society. Stanford, you can write papers forever. But when you build a product and it takes off, or you build a paradigm which takes off, that's great.
So once you got you generated the idea during the haircut, and then
for a patent.
For the patent, right? And then over time, you were able to connect with the NSF.
Very quickly we went to NSF, and my first connection was at DARPA, which we got turned down. I preserved all those letters with me, and then I went to NSF, and I got some money. NSF doesn't pay much.
And that provided kind of the seed funding.
And demonstrate. It grew. Then I started getting some money from industry also, a little bit of money from industry.
And was it a similar approach where you found sort of a visionary at some of these companies that understood your...
With industry, I think I would tell them, frankly, the MIMO is a little bit far off because this thing requires digital modulation. It requires I talked to OFDMA, but it requires multiple antennas, and maybe a little early, but there are some subsets of this idea which we can do quickly. So I've got funding around the idea of smart antennas more broadly, and already kept MIMO saying that is something to be done. But in '97, when I started doing experiments, I said it really works well. And by the time digital had come in, GSM had come in, and people were talking a little bit about CDMA. So we were into the digital world. So then I led to start the IOSPAN. And so it sort of transitioned well, but clearly the idea came at Stanford. The original basic work was done at Stanford, but I think the interesting work of making things, we get a lot of satisfaction making things, seeing things working. We did some prototypes at Stanford too, but it's always very simple. But to get a real product to work, that was hugely satisfying. That was in a company.
And then how did you kind of tactically navigate the first 100 days of the startup? Did you go on Sand Hill Road and pitch 20 investors?
Yeah, it turned out money was always easy for me. First I actually had a lawsuit on my hands for not taking money, so wow. Potential lawsuit. So it was that easy. Mm-hmm. The second time also, the money just walked in. So money is never...
Because you're already a proven successful entrepreneur.
The third time also, money was never been a problem. The problem was to make a success with the company and to execute. There are always differences of opinion, and sometimes you hire people who turn out to be disappointing, and sometimes you have to get rid of them. All those things. It's always the human factors that are the tough things.
Yeah, actually, I'm curious about that. What's your approach when you hired somebody and you thought their potential was great and they were going to have the impact you were looking for, but it didn't work out? How do you approach separating?
The thing is that I always played the cheeky game, but I never CEO. I was always CTO. I always was a CEO guy. So when it came to axing people, it was not my signature, it's his signature. Sometimes I opposed him. I would even once or twice I remember saying that I will not resign. I will give my job to that guy, and I want to protect this guy. I don't want to let him fire. I don't want to be fired. But so I would always act like a good cop. But I knew that the real tough person was the CEO, and his job to do it. So I never had the problem of really facing somebody and saying, "I'm firing you." So. I took the easy way off.
How did you find? It sounds like the CEO was kind of a partner in.
I think they're always there, but
like the CEO wasn't one of your grad students, for example.
No, they were usually from industry.
And then the venture capitalists connected.
Not venture. I think the first CEO came through my VC firm. Second CEO came in at the founding level itself, and third CEO also I knew I hired him. But CEOs also may not land up in the point. And your vision of the company and his vision may be different also, and I've seen it happening.
How did you deal with that? The differences?
Well, but I would always tell everybody that I started this company, and I'm the last guy to put the switch lights off. So I'm going to be here to the very end, and everybody can leave, but I'm not leaving. So whenever there are differences, essentially it survived the company. Maybe there were differences, but.
And did you ever have a company that you started that failed? Or it sounds like every single one of your companies.
I think when the multiplier, I think the best amount I spent it really well in terms of multiplying money. Rasa was okay. No, I think no abject failure, no bankruptcies. No. But that doesn't mean good companies can also go that way. It's just, if at all I was reasonably lucky.
You had luck.
I think
I learned a lot.
Yeah,
we
gave a great
enjoyed our conversation.
Learned a lot about India. Learned a lot about Stanford. Super interesting.
And Stanford, is a wonderful environment for every way. It's a great university. I think it mixes scholarship. It does allow entrepreneurship like this to happen, and so it's. We can't beat the environment Stanford provides both. So it's very fortunate to be here, and I had a very unusual background. I really didn't have any proper education. In the Navy, we really were trained. I was trained straight away to maintain radars. I never had no basic training at all, no basic foundation at all. I got it myself on my own. But from there to become a Stanford professor, that was they took a huge leap of risk on me because I had nothing except for that Esprit stuff, and of course all the sonar and all that didn't interest them.
So you became a professor, but you felt a little bit unqualified in a way. But you decided to go for it.
I think they took a risk on me. I felt confident I will do well. I'd done well before, but I think for them I was normally Stanford doesn't hire outside Berkeley and MIT and all that. And here's a guy from India, from Indian Navy, who really had no proper education.
Yeah, what was the thinking behind them?
I think there was this Esprit algorithm which I did here.
Okay.
That has become so well known, and they didn't really care what I did in India. But I think they convinced them that maybe we should give them a try. And within a few months, MIMO came, and it turned out to be a good bet for them.
Yeah.
So they were kind of thinking, well, we don't know about his India stuff, but if he built Spree, he's got to be good. Let's take a shot.
Only Spree is the only reason why I could get him in. And Spree was very big. It had entire conferences held on Spree. Entire conferences. So it was, and everybody would always ask me, how did you come out with the idea? It's so different. So different. And I said, if I was trained in the US, I'd got my PhD, and I would never have done it because I've done it on the groove.
Yeah, I'm from India. I was trained differently. I think differently than canonical.
Even MIMO, I think, came because I was different. It wouldn't be difficult for people in the groove to do it, I think. You had to think differently.
That's cool. You kind of turned your disadvantage in a way to a huge advantage because you could think.
Certainly, I think both these were very, very new ideas. And I think it's something to do with the fact I'm a total outsider.
Now you're an insider. You've been here long enough.
Well, I'm moving into AI now, so I'm outside there too.